Hi, and welcome to day 15 of Just Start Programming, the Rust programming language. I would like to take this time to congratulate you as my programming buddy who is viewing this content right now. And if you have been faithfully viewing my recorded stream since day 1 until today, then I'm sure that by now you could easily follow through what I'm showing you guys live. Or better yet, you could program better than I do. I know that day one I was so inexperienced and even the video was not that high quality as I just wanted to start programming. I don't have the time to fix it yet. Perhaps when we finish day 30, then I will edit all the videos and make it concise. So my approach is simple. I'm doing it live in one take, no shortcuts. You see me make mistakes and perhaps you will see me get things right as well. So, no preparation, no secrets. I admit I'm not an expert, but if we do this journey together, then perhaps we can gain some insights, discover new things, and learn something as we go along. So, today it's just timely that we get to create or build a command line program. Sounds exciting. Well then, let's start. All right. So according to the Rust book, an IO project building a command line program. So this chapter is a recap of the many skills you've learned so far and an exploration of a few more standard library features. We'll build a command line tool that interacts with file and command line, input-output. To practice some of the Rust concepts you now have under your belt. Rust, speed, safety, single binary output, and cross-platform support make it an ideal language for creating command line tools. So for our project, we'll make our own version of the classic command line search tool grep. Grep or globally search a regular expression and print. Oh, so that's what it means. Globally search a regular expression and print. In the simplest use case, grep searches a specified file for a specified string. To do so, grep takes as its arguments a file path and a string. Then it reads the file, finds lines in that file and contain the string argument and prints those lines. Okay, so grep takes its arguments, a file path, and a string. Then reads the file, finds lines in that file that contain the string argument and prints those lines. Okay. Along the way, we'll show how to make our command line tool use the terminal features that many other command line tools use. We'll read the value of an environment variable to allow the user to configure the behavior of our tool. We'll also print error messages to the standard error console stream, stdr, instead of standard output, stdout, so that, for example, the user can redirect successful output to a file while still seeing error messages on screen. One Rust community member, Andrew Gallant, has already created a fully featured, very fast version of grep called ripgrep. By comparison, our version will be fairly simple, But this chapter will give you some of the background knowledge you need to understand a real-world project such as RipGrep. Our grep project will combine a number of concepts you've learned so far. Organize code, using vectors and strings, handling errors, using traits and lifetimes where appropriate, writing tests. We'll also briefly introduce closures, iterators, and trait objects, which is chapter 13 and 18. Okay, so there are advanced topics as well, closures, iterator, and trait objects. Okay, so it means that it's a review. Okay, it's a recap of all these concepts and then new concepts as well. And then maybe let's research about Andrew Gallant. Rip grab. Burnt sushi. Okay. Let's see. Rip grab is here. Two years ago, 3 months, 2 years. Okay. Latest was September 9. Oh, there are a lot of contributors now. So 94% of it is coded in Rust. Okay, we can use this as a reference also later on how we can improve this application. Okay, so let's start. Accepting command line arguments. Let's create a new project with, as always, cargo new. We'll call a project mini grep to distinguish it from the grep2 that you might already have on your system. Okay, so let's go right here. Let's put this aside. Test. Yeah, so we were doing tests yesterday. How to make a test. And then cargo new. What's that? Mini grep. Oops. Cargo new. Mini grep. Mini grep. Okay. First task is to make mini grep accept its two command line arguments, the file path and a string to search for. That is, we want to be able to run our program with cargo run. Two hyphens to indicate the following arguments are for our program rather than for cargo. A string to search for and a path to a file to search in, like so. Cargo run search string example. Okay. We don't have to copy this now. Right now, the program generated by cargo new cannot process arguments we give it. Some existing libraries on crates.io can help with writing a program that accepts command line arguments. But because you're just learning this concept, let's implement this capability ourselves. Reading the argument values. To enable minigraph to read the values of command line arguments we pass to it, we'll need the stdenv function provided in Rust's standard library. This function in chapter 13. For now, you only need to know two details about iterators. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector that contains all the elements the iterator produces. The code in listing 12-1 allows you your mini-grep program to read any command line arguments passed to it, and then collect the values into a vector. Okay, so file name. Okay, so let's prepare visual code. So maybe we can close all of this. We are done with that. And here, code. Just check if everything is working. Hello world. Okay. Okay, here we have main std env. It was saying something about args. Okay, args. So args is actually here. Oh, no, here. Env args dot collect. Okay, let's copy this. Okay, let's do a little bit of analysis. So this is under env. So since we did not put args here, we can change this a little bit to look like, is it possible? Put args here, args, yeah. So we only have args here, and let args equals to, so args, what does it do? It turns the arguments that the program was started with normally passed via the command line. First element is traditionally the path of the executable, but it can be set to arbitrary text and might even exist. This means our property should not be relied upon for security purposes. Okay, it says path. So in Unix system, the shell usually expands unquoted arguments with glob patterns. On Windows, this is not done, and such arguments are passed as is. Used argument with arguments. Prints each argument on a separate line. And then what about collect? Okay, so it returns on it, do a bunch of transformation and collect at the end. Collect can also create instances of types that are not typical collections. For example, a string can be built from car and an iterator. Okay, items can be collected into result collection. Let's see. Okay, so transformation can be done, and then take a collection, and then it's here. Then we see args. Okay, maybe let's run this one. What does it show? So target debug mini graph. Let's do a tree and see. So it went inside target debug, and you have mini graph, because when we run it, it's executing this one. So it returns the path. Okay. How about if we do something like cargo run testing 1 2 3. Testing 1 2 3 is there. So how about one? How about dash dash? Unexpected. Oh, okay. Because now I think run will be anticipating something. But if we put the dash dash testing 1 2 3 4 here. Okay. Okay. Next. First, we bring std env module into the scope. A use statement, so we can use its args function. Notice that the args function is nested in 2 levels of modules. Yeah. In cases where the desired function is nested in more than one module, we've chosen to bring the parent module into scope rather than the function. By doing so, we can easily use other functions from std-env. Okay, so that's the purpose. So we can use other modules, so it's not good to just limit it to args. So that is possible. So we put args here, args, colon. env, not args, but env. env. So if we run this, let's see, work. Okay, so it's still working. All right, so by doing it like this, it means that other functions can be used at this level. So maybe not just args, but something else. Or maybe we can take a look. Just a quick peek. Let's see, env. This is what else? Args, current dir, home dir, join paths, current exe, home dir. There's so many functions here. So if we do let's just try it out. V colon args os, and we enclose this in. I think this should be returning args os. If it's arg os, how can we use it? Argument. Okay. For, so it's a for loop. Argument in for argument in Debug. Let's use debug. It's more convenient. Let's see. Argument. Yeah. Argument, minigraph. So it's the same, almost the same. On Unix systems, the shell usually expands. Note that the return iterator will not check if the arguments to the process are valid Unicode. If you want to panic on UTF, use args function instead. Okay, so args is better. So I can delete this. Then let's continue. B, because args might easily be mistaken for a function that's defined in the current one. Okay. The args function and invalid Unicode. Note that std args will panic if any arguments contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use. Okay, so it will panic if we use args. But if we want our program to accept arguments containing invalid Unicode, then we can use args OS instead. That function returns an iterator that produces OS string values instead of string values. We've chosen to use args here for simplicity because OS string values differ per platform and are more complex to work with than string values. On the first line of main, we call env args, and we immediately use collect to turn the iterator into a vector containing all values produced by the iterator. We can use collect function to create many kinds of collections, so we explicitly annotate the type of args to specify that we want vector of strings. Although you very rarely need to annotate types in Rust, collect is one function you do often need to annotate because Rust isn't able to infer the kind of collection you want. Finally, we print the vector using a debug macro. Let's try running the code first with no arguments and then with 2 arguments. Okay, so I think we have already tested this part. So that's the purpose of this double dash with a space. Notice that the first value in the vector is target debug minigraph, which is the name of our binary. This matches the behavior of the arguments list in C. Letting programs use the name by which they were invoked in their execution. It's often convenient to have access to the program name in case you want to print it in messages or change the behavior of the program based on what command line alias was used to invoke the program. But for purposes of this chapter, we'll ignore it and save the 2 arguments as arguments we need. Okay. Saving the argument values in variables. Program is currently able to access the values specified as command line arguments. Now we need to save the values of two arguments in variables so we can use the values throughout the rest of the program. We do that in listing 12-2. Okay, so collect, it is returned here, and then okay, at the referencing args, and this is the second element. Yes, it should start from 0. 0 is this one. So query is needle, and then args2 is haystack. Needle haystack. And then print search for query in file path. Okay, let's copy this part. So we can remove this. Okay. And then we run it using this one. So it's better if we run it from here. Okay, searching for test in file sample.txt. Test sample.txt. Searching for file, searching for test. Okay, because test was the element at indexed 1. Great, the program is working. The values of the arguments we need are being saved into the right variables. Later, we'll add some error handling to deal with certain potential erroneous situations, such as when the user provides no arguments. For now, we'll ignore that situation and work on adding the file reading capabilities instead. Reading a file. Now we'll add functionality to read the file specified in the file path argument. First, we need a sample file to test it with. We'll use a file with a small amount of text over multiple lines with some repeated words. Listing 12-3, okay, has an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your project and enter the poem. I'm nobody. Who are you? Okay, so we need to create a poem.txt at the root level of your project. Three done. So root level should be here. Okay. AI. Oops. Was I doing? Should be poem.txt. With the text in place, edit source main, add to the code to read the file in listing 12 dash. Okay. Yeah, so this one, fs. Okay, so we need to add this one. And read to string file path that expect should have been able to read the file. Okay. So we need to add use std fs. And here fs read, or what was it? Read to read to string. Read to string. The file path would be the file path from the argument. File path. And then we will store that in contents records. Okay, so there would be a result. Oops. Expect the should have been able to read the file. Format the document. Can we just put it here? This. And contents. Okay, we can print contents. With text, so /n is the new line and then it will display contents. Let's run from here. Oops. Yeah, because you cannot specify the file path. Okay, so how do we run it? We run it from here. Cargo run. We use -- and poem the text. Index out of bounds. The len is 2, but the index is 2. What was wrong? Because we have query. So we need to put sample, could be anything, just put sample there. Searching for sample in file poem.txt with text and nobody. Who are you? Are you nobody? 2. Okay. Okay, here, so main new statement with toString takes the file path, opens that file, and returns the value of type result string contains the file's contents. After that, we again add a temporary print line statement that prints the value of contents after the file is read, so we can check that the program is working so far. Let's run this code with any string as the first command line argument, because we haven't implemented searching part yet. In the poem.txt file is the second argument. Yeah, so this one they use the. So searching for the in the file poem.txt with text. This one. Great, the code and the printed the contents of the file, but the code has a few flaws. At the moment, the main function has multiple responsibilities. Generally, functions are clearer and easier to maintain if the function is responsible for only one idea. The other problem is that we're not handling errors as well as we could. Yeah, because we just had the expected function. The other problem, okay, the program is still small, so these flaws aren't big problem. But as the program grows, it will be harder to fix them cleanly. It's a good practice uh, to begin with. It's a good practice to begin refactoring early on when developing a program because it's much easier to refactor smaller amounts of code. We'll do that next. Okay, so we'll be refactoring the code. Let's see. Factoring to improve modularity and error handling. To improve our program, we'll fix 4 problems that have to do with the program structure and how it's handling potential errors. First, our main function now performs 2 tasks. It parses arguments and reads files. As our program grows, the number of separate tasks the main function handles will increase. As function gains responsibilities, it becomes more difficult to reason about, harder to test, and harder to change without breaking one of its parts. It's best to separate functionality so each function is responsible for one task. This issue also ties into a second problem. Although query and file path are configuration variables to our program, variables like contents are used to perform the program's logic. The longer main becomes, the more variables we'll need to bring into scope. The more variables we have in scope, the harder it will be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. Third problem is that we used expect to print an error message when reading the file fails, but the error message that just prints should have been able to read the file. Reading a file can fail in a number of ways. For example, the file could be missing, or we might not have permission to open it. Right now, sorry for that. Right now, regardless of the situation, we'd print the same error message for everything, which wouldn't give the user any information. So error handling will be applied here. Fourth, we expect to handle an error right here. And if the user runs our program without specifying enough arguments, they'll get an index out of bounds error from Rust. Yeah, that's what we encountered earlier. Error from Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place, so future maintainers had only one place to consult the code. If the error handling logic needs to change, having all the error handling code in one place will also ensure that we are printing messages that will be meaningful to our end users. Let's address these 4 problems by refactoring our project. Separation of concerns for binary projects. Okay. The organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. As a result, the Rust community has developed guidelines for splitting the separate concerns of a binary program when main starts getting large. This process has the following steps. Okay. Split your program into main.rs file and lib.rs file, and move your program's logic to lib.rs. As long as your command line parsing logic is small, it can remain in main. Okay. When the command line parsing logic starts getting complicated, extract it from main.rs and move it to lib.rs. The responsibilities that remain in main function after this process should be limited to the following: calling the command line parsing logic with the argument values, setting up any other configuration, calling a run function in librs, handling of error if run returns an error. This pattern is about separating concerns. Main.rs handles running the program and lib.rs handles all the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all of your program's logic by moving it into functions in lib.rs. Okay. The code that remains in main.rs will be small enough to verify its correctness by reading it. Let's rework our program by following this process. Extracting the argument parser. We'll extract the functionality of the parsing arguments into a function that main will call to prepare for moving the command line parsing logic to source librs. Okay, so in 12-5 shows the new start of main that calls a new function parse config, which we'll define in main.rs for the moment. Okay, so here, so we retain this one, it will be args, then parse config, and then we have a function parse config. Okay, so let's refactor it. Copy this. It's here. And we'll have that query file path parse config. Query let query file parse config a reference of args still collecting the command line arguments into a vector. But instead of assigning the argument's value at index 1 to the variable query, and the argument value at index 2 to the variable file path within the main function, we pass the whole vector into parse config. Okay, so now we have a function to handle. Okay, so we just move query and file path here, and it's being returned as a tuple. Okay, we still create the query and file path variables in main. This rework may seem like overkill for a small program, but we are refactoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. It's good to check your progress often to help identify the cause of the problem when they occur. Okay, so let's see, query. So we need to remove this. It's not needed anymore. Can run it from here. Let's see. Yeah, because we did not specify anything, so it panicked. Index out of bounds. Okay, so the behavior is still the same. Okay. Grouping configuration values. We can take another small step to improve the parse config function further, the moment we're returning a tuple. But then we immediately break the tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. Another indicator that shows there's room for improvement is the config. Config part of parse config. Config part of parse config. Config part of parse config. Is it referring to this one? Which implies that two values we return are related and are both part of one configuration value. We're not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. We'll instead put the two values into one struct. Okay, so now we have an opportunity to create our struct and give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers this code to understand how the different values relate to each other and what their purpose is. Okay, shows the improvement of parse config function. Okay, so it created a struct config. Okay, so the fastest way is we copy this. Put it here. So now we have a parse config. Parse config. And then so instead of returning like this, we can have, okay, let me try to attempting to modify this one. Okay, so we're not returning this anymore, but it's going to return a config, and then here we put let very config with this, and then query as query, and file path was, oh, now they look the same. Okay, let's try. Can we return? We can shorten this a bit. We can just return config like this. Yeah, of course this one will complain, so let's modify this. Config. And here instead of query, it's going to be config.query. Config. Okay, let's try to fix this. Invalid format string expected found. Okay. So it should be that one. Why is it having an error? Okay. Field access isn't supported, not supported in format string. Consider using a positional formatting argument instead. Okay, so that's how it works. And this one is 1. No, 0. What? There's no closing quote. Okay, there's a double quote. Remove that. Then here, read string. Okay, so can we borrow that one? Should have. Then what's the issue here? Expected font config. Let result. Consider borrowing here. Okay. And this one, of course, it will complain because now we don't know which one we are using. String. We are referencing. Result. And then this one, what does it say? String found. Okay, it's already a string. So we can remove this. Okay, what's the issue? Mismatch. Expected string found ampersand string. Expected string found ampersand string. Try to use a conversion method to string. Okay. Dot to string. Dot to string. Okay, then result. Let return a value referencing a temporary value. Temporary value created result. Okay. Can result. What? Not return reference to a temporary value. Return a reference to data owned by the current function. Temporary value created here. 24 dash 6. Config. Okay, remove this one. Here it becomes config. Config. You need to put ampersand here. Okay. Let's try. Okay, it worked. So I've just realized it was the compiler was helping me fix the issues. So I just followed whatever errors we encountered. But finally it worked. It worked. Woohoo! Okay. Let's see if it matches to oh, it looks a bit different. So it's a surprise. So this one we copied, and then here we can just return config query file path. I think here I did it explicitly. That one worked as well. And then here, parse config at args won't change, but it's going to be config without the ampersand. And then here, config query, config file path. Here I was trying to borrow, which means if we add something here, debug config dot file path. Yeah, that one will complain, definitely complain. So this one will show the config file path. If we run it, config file path, so it's still there because we're borrowing it. But if here I remove this, I cannot use it here anymore. Yeah. So we have learned something a little bit. Okay, so I'll remove this one, make it look exactly as the book mentioned. So here query, instead of doing it like this, I remove it. Don't want toString. Oh, it did a clone. It cloned it. Okay. So clone of args1. Clone means it created its own copy. Okay, so it created its own copy. Okay, but here, if I put in debug again, yeah, it should still complain. Copy of the value. It's totally new. Okay, so let's run that one. Okay, let's continue. Config query file path. Yeah, so I think this one will explain. So it's a string slice that references string values in args. Okay, a number of ways you can manage the string data. Yeah. I think the one I did was the first step, although I was not exactly clear and the Rust compiler guided us through. And trade-offs of using clone, yeah, of course. Trade-off of clone. To fix ownership problems because of its runtime cost. Yeah, because there's a runtime cost if you do clone. Chapter 13, you learn how to use more efficient methods. So that's when we use the reference instead, we are borrowing. As you become more experienced in Rust, it'll be easier to start the most efficient solution. But for now, it's perfectly acceptable to call a clone. We have updated main, so it places the instance of config returned by parse config into the variable named config. Config. Mm. And we updated the code that previously used separate query variables and now use okay. Clearly conveys that query and file path are related and their purpose. To configure how a program will work, any code that uses these values knows to find them in the config instance in the field's name for their purpose. So yeah, we have just created a struct and used it. Creating a constructor for a config. Okay. So far we have extracted logic responsible for main. Doing so helped us see the query and the file path values we were related. And that relationship should be conveyed in our code. We then add a config struct to name the related purpose of query and file path. To be able to return the values named as struct field names from the parse config function. So now the purpose of parse config function is to create a config instance. We can change parse config from a plain function to a function named new that is associated with config struct. Making this change will make the code more idiomatic. We can create instances of types in the standard library such as string by calling string new. So that is for string. New is the constructor. Similarly, by changing parse config into new function associated with config, we'll be able to create instances of config by calling config new. So the struct will have a new function. Okay, so let's see. Config new. Okay, so this is the goal. You'll have a config new. So it's just to replace the structure and the signature. Okay, so config column new. So here new. Mm, I think we need to do IMPL. IMPL config. Okay. Yeah. So we implemented struct config to have a function new instructor. And then let's run. Okay. Yeah. So it looks the same. Query file path config mpl config of the struct, although we don't see the struct here. Okay, we have updated main where we are calling parse config to instead call config new. We've changed the name parse config to new and moved it within impl block, which associates the new function with config. Try compiling this code again to make sure it works. So we have already done that. Now we'll work on fixing our error handling. Recall that attempting to access the values in the args vector index 1 or index 2 will cause the program to panic if the vector contains fewer than 3 items. Try running the program without any arguments. It will look like this. Okay, so we can see that here. So we cannot pass any argument. Panicked. Index out of bounds. Some details were omitted. So we'll improve. Improving the error message. We add a check in the new function that will verify the slice is long enough before accessing index 1 and index 2. If the slice isn't long enough, the program panics and displays a better error message. So here, okay, so we are going to check len is less than 3. Panic, not enough arguments. Okay, so let's do that. So it should be if args len is less than 3, message not enough arguments, not enough minerals, not enough arguments, so it will panic. Let's see, run here, not enough arguments. Okay, code similar to the guessing game. Okay, very called panic when the value arguments was out of range and value. Instead of checking for a range of values here, we're checking the length of args is at least 3. And the rest of the function can operate under assumption that this condition has been met. Why 3? Because we have to start, we need to include the first one, which is the application itself, or the first one. first argument is actually at index 1. The rest of the function can operate under the assumption that this condition has been met. If args has fewer than 3 items, this condition will be true, and we call the panic macro to end the program immediately. With this extra few lines of code in new, let's run the program without any arguments. Okay, not enough arguments is shown. This output is better, but now we have a reasonable error message. However, we also have extraneous effort we don't want to give to our users. Perhaps the technique we use in listing 9-13 isn't the best one to use here. Call to panic is more appropriate for programming problem than a usage problem. Chapter 9. Instead, we use other technique we learned about Chapter 9, returning a result that indicates success or an error. Okay, so this time it will be using result. Okay, let's see. I'm going to change the function name new to build because many programmers expect new functions to never fail. Oh, new functions to never fail. So it always creates something. When config build is communicating to main, we can use the result time to signal there was a problem. Then we can change main to convert an error variant into a more practical error for users without surrounding text about thread main and Rust vectors with call to panic process. Okay, listing 12-9, need to make to the return value of the function. We're now calling config build, and the body of the function needed to return a result. Note that this won't compile until we update the main as well, which we will do in the next listing. So let's try this one, and also at the same time let's update the main. So this one, it returned, okay, something different here. So config and static string. So result will have error, okay, and error. Okay, let's copy this part at least. Okay, so instead of config, we will wrap this with this. Oops. So instead of panic, we'll do an error. Not enough arguments. Then, of course, we need to implement okay. Then inside okay, we will have config. I'll put it here. Okay, then like this. What's the problem with error? What's that? Oh, need to return error. Return error. Okay, immediately it will return and result will be error. Okay, but this static string, where will it go? Okay, so let's fix this one. config now is going to be result, so it's not query anymore. Config, okay, it's going to be okay. Can we put a new, we'll change to build, and build. Okay, and then here, colon, okay. How do we extract the information from result again? I think I already forgot. It's error in config. How do we extract config if config equals no set match config okay, okay, okay. Then here we have conf or cfg. Let me put cfg config. We do fat arrow, do something like this. So now I need to put, okay, so like this, but let's put it here. And of course, you still need to so this one should have comma, then error. No, should be remove that. Query, so this is now cfg, cfg, this one is cfg. Error was not covered. Error is here. Oh, like this. Maybe we can put panic here. And but not enough argue arguments. Okay, it's the error node. Expected semicolon. Expected expression. Config. Greater than equal sign. Remember, there should be a comma here. Then, what? Oh, something is missing. Okay, so that one should be this and that one. Config. And then I should remove this. Then here, in error, you can put like this. Panic. Not enough arguments. Okay, what's the error here? Pattern of 0 fields. Underscore. Then, yeah. So this one is now closing. So let's put this one. Okay, so it matches that one. Okay, not enough arguments. So let's run this. And not enough arguments. And then from here, should work fine. Yeah. Okay, so it took me some time, but yeah, so we managed to implement it. Match config, config. Okay, config, CFG. It's now CFG. Build. Okay, build. Build return result. So build itself will not panic, but here, this is where we handled panic. Not enough arguments. Okay, let's see. Let's see. Ending errors. Okay, okay. Config. Oh. Unwrap or else. Unwrap or else. So this is a much simpler approach. Okay, unwrap or else, which is defined on result TE by the standard library. Using unwrap or else allows us to define some custom non-panic error handling. Okay, okay. So the goal was actually do something which is non-panic. If the result is an OK value, this method's behavior similar to unwrap. So it will unwrap it. It returns the inner value that OK is wrapping. However, if the value is an error value, this method calls the code in. Oh, no wonder, because this is a closure. So this is totally new. Which is an anonymous function we define and pass an argument to unwrap or else. It will pass an inner value of which in this case is a static string, not enough arguments. Not enough arguments. Oh, because of this. Not enough arguments is there. The closure in the argument it appears between vertical pipes. The code in the closure can then use value when it returns. Okay. So yeah, so it's a closure. I don't know what that is, but it will look like this. Process exit 1. Okay, so maybe let's copy this one instead. Yeah, this one is a nice try, but that's not the goal. So put it here. Where else? Yeah, but we still need to read the contents. Config will still be here. Oh, okay. So this is already config. It returns config if it's successful. Type T. Okay. So it means we don't need to handle this one anymore. This one we can remove. Okay. Here we can move this back. Oops. And we can change CFG to config. Oops. Then what's the problem here? Process exit. I think there's a missing semi curly brace here. No, right here. Set. So this is supposed to be fine. Config expected config found this one. Remove the semicolon. and process. Fail to resolve, use of unresolved module and link. Create process. Oh, and what is process? Import process. Which process? Standard. Okay. Core panic. Panic is no longer used because we didn't use panic anywhere here. So we can remove that. Okay, so let's run. Not enough arguments. Okay, so that looks better because we did not use panic. And then here, if we use enough arguments, correct. Okay, let's continue. We added a new use line to bring process. Okay, so that was added by the quick fix. And then call process exit. The process exit function will stop the program immediately and return the number that was passed as an exit status code. Let me see that. There's the number. There's no number. Exit code 1 here. Okay. Similar to panic-based handling we use in listing 12-8, but we no longer get all the extra output. Yeah. Okay, great. Extracting logic from main. Okay, so now that we have finished our factoring configuration parsing, let's turn to the program's logic. As we stated in separation of concerns for binary project, we'll extract a function named run that will hold all the logic currently in the main function that isn't involved with setting up configuration or handling errors. Then we're done. Main will be concise and easy to verify by inspection. And we will be able to write tests for all the other logic. Okay, so listing 12-11 shows extracted run function. For now, we're just making the small incremental improvement of extracting a function. We're still defining the function in main.rs. It's not in lib.rs yet. So we're going to extract a function run. Okay, let's copy this one. Function is still in main. Okay, then here, where shall we put it? We can put it here. So how do we extract function run? So we're moving the read to string. Okay, this part here. So meaning we're passing config. So we'll clear this part. And then we'll just do a run config. Shall we borrow? Do we need to borrow? I think there's no need to borrow because we're not using config anywhere after this. Okay. Query. What's wrong with query? Query is never used. Not enough arguments. Warn that code on by default with text. Searching for sample in file. Okay, so it only started with this. Okay, because we commented it out. Config query, config file path. Okay, the run function now contains all the remaining logic from main, starting from reading the file. The run function takes a config instance as argument. Yeah, so it looks much more cleaner now. Let's come back here. I commented it out. Yeah, run is here. Config, we're building config configuration, building the config configuration. Then we're passing it here and then we're running. Okay. Next, the run function now contains all the remaining logic from main, starting from reading the file. The run function takes a config instance as an argument, returning errors from the run function. With the remaining program logic separated into the run function, we can improve the error handling, as we did with config build. Instead of allowing the program to panic calling expect, the run function will return result, T and E, when something goes wrong. This will let us further consolidate the logic around handling errors into main in a user-friendly way. Listing 12-12 shows the changes we need to make the signature and body of run. Okay, so run should use, what is this box? Oh, now it introduced something new. Okay, well, let's just copy this. Result. Where is run? Run is here. So we insert. And okay. So the question mark is added here. Then this one, you return okay. No, like this. Error. Decline contents. This error, I think it's something we need to consider importing this trait. Yeah, we need to import. Which error? stdio error, std error, error, error. Is it error? Yeah, error. Okay. Then we bought error in scope with the use statement in the top. We cover traits. For now, just know that box dyn error means a function will return a type that implements the error trait. Now we don't have to specify what particular type the return value will be. This gives us flexibility to run error values that may be of different types in different error cases. The dyn keyword is short for dynamic. Second, we remove the call to expect in favor of the question mark operator. As we talk about in chapter 9, rather than panic on an error, this one will return the error value from the current function for the caller to handle. Third, the run function now returns an OK value in the success case. We've declared that the run function success type as this one in the signature, which means we need to wrap the unit type value in the OK value. This is OK. Syntax might look a bit strange at first, but using this, like this is the idiomatic way to indicate we're calling run for its side effects only. It doesn't return a value we need. Okay. We don't need to return any value. Okay. When we run this code, it will compile but display a warning. Yeah, this one. Actually, we have already seen it here. Oh, sorry, my mouse is jumping. Where were we? Yeah, so we're over here. So in main, we can do something like this. Run config error print line. Okay, let's see. Quick fix. Let's see. Ignore let run returns error. If let which error e and we remove this one. Oops. This E. Print line application error process exit one. Print line application error. Exit. Process exit one. Exit one. Okay. Let's run this one. Not enough arguments. And here. Okay, the only warning we had now is the query part. Splitting code into library crate. Our mini graph project is looking good so far. Now we'll split source main file and put some code into source lib file. That way we can test the code and have a source main.rs file with fewer responsibilities. Let's move all the code that isn't in the main function from main.rs to source lib.rs. The run function definition, the relevant use statements, the definition of config, the config build function definition. The contents of source lib.rs should have the signature shown in 12-13. We've omitted the bodies of the functions for brevity. Note this won't compile until we modify main.rs in listing 12-14. That's here. Okay, so there's lib.rs, config, implementation of config. Yeah, so we add this in, we have the run, and then we made liberal use of pub keyword on config. Okay, because now this is a module. Module by default is private. So we need pub. Then here we need pub function. And then run should be pub. We now have a library crate that has a public API we can test. Now we need to bring the code we moved to source lib.rs into scope of the binary crate in main.rs. Okay, in main.rs you use minigraph config, and then here main.r. Okay, then we just keep it there, except that you have a use module like this. We add a minigraph config line to bring config type from the library crate into the binary crate scope, and we've prefixed the run function with our crate name. Now all the functionality should be connected and should work. Run the program with cargo run and make sure everything works correctly. Phew, that's a lot of work. We've set ourselves up for success in the future. Now it's much easier to handle errors, and we've made the code more modular. Almost all of our work will be done. Let's take advantage of the newfound modularity by doing something that would have been difficult with old code but easy with the new code. We'll write some tests. Okay, so okay, so here's what we are going to do. On the next day, we'll do a live stream again, but instead of peeking into no, we should do this together. Yeah, we will do this together and see if we know how to create library. I remember when we create lib.rs, we need to do a cargo new --lib.rs, but I'm a bit scared because it might overwrite main.rs. Yeah. Or should we try that at least? Let's see if it will overwrite. Anyway, we need to experiment. This is main.rs. We don't have lib.rs yet. So here, what I'm going to do is cargo new mini grep --lib. Let's see if it will be gone. Oh, it created mini grep source lib.rs. Amazing. That's great. And it means here we can do something like use minigraph Ini grep colon column, or can we do something like that? Mini grep. No external create mini grep. Can we do a cargo build? What? Oh, I think we made a mistake. It created mini graph with another cargo.toml here. Let's delete. Cargo. Oh, because we are already in mini graph. So can we do cargo new mini graph dash lib? So it cannot create because we already have mini graph. Source. So we'll do it the hard way. Lib. Lib, and then here we insert lib.rs under lib. But lib is lib. And this one we move here. Okay. And this one mini graph testing. Okay, something like that. Mod testing. It is empty. It's wrong. Cargo.toml. So let's put here, what should we put here? Dependency package. Mini graph. Did it work? Here it worked, but what is this? Unexpected character M while parsing major version. Hmm. Can we do something like 0.1.0? Say sure. And we get rid of this. Cargo build. How do we do the library again? Common collections, method, modules. Where is the module? Backyard. I think this one. The Tama. Let's take a look at Cargo the Tama. And then 3 dot. Source. Garden. Everything is source. Where's the library? Source lib.rs. It's not lib. Okay. So we grab. Let's go back to this one, and then we just move it here. And then we remove library. Module testing is private. Let's make it okay. Don't want to remove that one. So this one should still work, and this one should still work. That's it now. No such file. Because it was sample.txt, should be form.txt. There. Okay. So let's end here. Thank you so much for keeping me company. I hope you learned something as well. See you on the next day.